I'm really excited about today's lesson. We're going to be talking about rational exponents. That's exponents that are fractions. Look, this can be very overwhelming when you don't understand the basics. So I'm going to teach you the basics. It's going to be so easy, and it's going to look so complicated, and you're going to understand it, and it's going to make you feel good. You'll see, I promise. In fact, the way I'm going to show you right now, I've shown this same method to, well, hundreds of students, and well, thousands of students, and it always goes well, and they remember it really well. And I've shown it to lots of other teachers, and every time I do, they're like, whoa, that is so cool. So we're going to do it. As always, though, pause the video, try the practice problems, write questions. When you answer your questions, come back, write your answers. Right? Let's get to it. Check this out. We're going to be talking about rational exponents. Those are exponents that are fractions like this. I'm going to show you how that works today. I'm going to tie it into division, and man, it's going to be awesome. So first of all, we know the relationship between multiplication and exponents, right? Multiplication is repeated addition. So when you write 5 times 3, that really means 5 plus 5 plus 5. Of course, it could mean the other way, 3 plus itself 5 times, but we're going to go this method, right? That tells you how many of these, the second number tells you how many of those are adding. Now they're written like that with that little symbol in the middle. That's what it means, repeated addition. When you have an exponent, you have what's called actually a superscript. When it's that tiny little thing up at the top, it's called a superscript. So 5 with a superscript of 3. That means the 5, which is the regular number, is the base. The 3 describes how many times that base is multiplying by itself. So 5 times 5 times 5, right? Now, here, this is multiplication, which, as we know, multiplication is repeated addition, but it's with a fraction. So here's the thing this is actually asking. What this is really asking is it's saying, it's asking a question about repeated addition. This right here means what added to itself 3 times is 27. That's what that says right there. This thing right here. That's what this means. This means what added to itself 3 times is 27. So what number added to itself 3 times equals 27? Do you see? That's what it means. So would you guys agree that it would be 9? 9 plus 9 plus 9 is 27. Now, of course, that's not how you do the simplification, because you've been taught, how many times does 3 go into 27, right? Of course, it's 9. But this is what it means. And if we can approach it what it means, then we can apply that same idea here. I'll show you. So this is equal to 9, because that's the number added to itself 3 times is 27. This is saying, because it's an exponent, exponents are talking about repeated multiplication. This one's multiplication, which is talking about repeated addition, what added. So this is what multiplied, what times itself 3 times is 27. That's what it's asking. So if you know the answer to that, then this is really easy to handle, right? So this is saying what times itself 3 times is 27. Well, that would be 3 times 3 times 3. 3 times 3 is 9, times 3 is 27. So this one's just plain old 3. So there's 2 things going on here. Look, number 1, if you know how to read it, what times itself 3 times, what times itself that many times is 27. If you can read it, and then if you just know the arithmetic fact, you're good to go. So cubes, usually you're going to be able to do those without too much of an issue, right? It could be squares, it could be a 4. Anything above a 4 is probably, the answer is probably going to be something to do with a 2. Like, if this number is more than a 4, your answer is probably going to have something to do with a 2. We'll get into that. I'll show you right now. Now, before we do, though, what if you had this? What's that equal? Well, the way you would do it, you'd say, well, 3 goes into 27 9 times 2 is 18. So, of course, it's 18, right? But what if, oh my gosh, what if we wanted to do it this other way? Oh man, I'm going to have to answer that one in just a second. Sorry about that. So what if we wanted to do this question this way, right? Well, this is saying what plus itself 3 times is 27. That's what this part is saying right here. What plus itself 3 times is 27. And then this says take 2 of them. So that means that 2 of them is going to be your answer. Well, we already know that 9 plus 9 plus 9 is 27, so 18. Good to go? Yeah, just like that. Now, what if you had this 27 to the power of 2 over 3? Well, this is actually going to be 9. Let me show you why. You see that 3? This 3 right here, just like before, it means what times itself 3 times is the base. So what times itself 3 times is the base. So what number times itself 3 times is the base? And then that 2 says we're going to take 2 of them. So we know 3 times 3 times 3 is 27. So 2 of them would be 9. That's how it works. Just that simple. Um, they do get more complicated. Like sometimes you don't have a number that is a perfect power of that. But usually it's not too bad. So a couple things you might want to know. Might want to know your cubed values of quite a few numbers. You already know your squares. You know your squares are what? 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, right? 121. If you're in my class, you should know all of these, right? 225, that's to 15. I think that's pretty reasonable. 1, now 2 squared is 8, or 2 cubed is 8. These are squares. These are cubes. So this is like the base squared. This is like the base cubed. So 1, 8, 3 squared is 27, 64, 125, 256, 343, all that, right? I don't have them memorized off the top of my head. Confident enough to write them in ink right now in a video, but I would go ahead and fill these rest of these out right here and then use those. So for example, I think it's maybe 216. Hold on. Let me see here. Watch. 6 cubed. Yeah, it is 216. 289. No. 343. Yeah, 343. 8 cubed. 512. 729. And then 1,000. We'll stop there. Okay, so this is 1, 2, 3, 4, 5, 6, 7, 8, 9, and then of course 10. So let's take a look at this right here. We know that that is 3. Sorry, we know that's 9 cubed, right? We know that's 9 cubed. So if you were to see something like what is 729 to the 2/3 power, well, it's going to be 81. So here's why I know that. We just said that 9 times 9 times 9 is 729, right? So this is saying what times itself 3 times is 729, then take 2 of those. So this is saying what times itself 3 times is 729, and then it says take 2 of those. So we know 9 times 9 times 9 is 729, so this is 81. Just like that. Now there's another way to talk about this. Watch, check this out. This is going to be our last thing. We know that 729 is 9 cubed. So then, if I took 729 to the 2/3 power, I can substitute that number right there, because those are equal. Do you see? Do you see what I did there? I took 729 and made it 9 cubed, because they're the same. They're exactly the same. So, like if I had 4 to the power of 1/2, well, that 4 is the same as 2 squared. Do you see? Same thing here. And then if you have a power raised to a power, don't you just multiply those? If you raise a power to a power, so if you had a to the power of b to the power of c, that would be a to the power of bc. So this would be 9 squared, which is 81, just like we knew. This would be 2 to the power of 1, which is just 2. Turns out, and this is going to be our last little idea for now, turns out that if you have an exponent of 1/2, that's the same as square root. You never write an exponent of 1, you never write that index right there. Oh, dang. Exponent of 1/3 is the same as cube root. What times itself 3 times is 729. Oh man, all right, we'll get into those things in the future. But for right now, here's what I would like to see that you could handle. Let's do 64 to the 2/3 power. How about 128? Let's see here. Oops, hold on. I just want to make sure I'm not doing something dumb here. Yeah. How about to the 3/7 power? How about 81 to the 3/4. Ooh, that one's kind of tricky. I haven't given you that math fact yet. That fourth thing there. Oh, that's going to be kind of weird. And then let's do one more. Let's do 343 to the 1/3 power. Why don't you try these four right here? See how you do. Now look, here's the deal. Here's the deal. Number one, you have to be able to read it. See that 3? We're looking for something times itself 3 times. It is 64. And the reason we're looking for repeated multiplication is because this is an exponent. It would be different if it was this. Here we'd be looking for something added to itself 3 times. It is 64. We take 2 of those. Here, what times itself 3 times is 64. Take 2 of them, multiply. What times itself 7 times is 128. Remember, I said if this is more than a 3, if that denominator is more than a 3, your answer probably has something to do with a 2. But not in this case. This one, explore the number 3. You'll see. And this one, of course, means what times itself 3 times is 343. So try those 4 right there. Unpause the video when you're done. We'll go over them. Ready? I'm going to do them now. 4 times 4 is 16 times 4 is 64. So this is 16 because 4 times 4 times 4 is 64. And the 2 says to take 2 of them. So 16. Good to go? This is 8 because 2 times 2 times 2 times 2 times 2, 1, 2, 3, 4, 5, 6, 7. That is 128. And so this says take 3 of them. 3 times 3 times 3. Or sorry, 2 times 2 times 2. 2 times itself 3 times is 8. This one is 27 because washa. Watch. 3, 9, 27, 81. Those are powers of 3. See, that is 3 to the power of 4. This is 3 to the 1, 3 to the 2, 3 to the 3, 3 to the 4. That's the third one right there, 27. And this one's just 7. The number times itself 3 times is 343 is just 7. So anyway, hope this has been helpful. You guys are killing it. Talk to you soon.